Let's begin. There's a couple of fun stories. A girl sits at the top of a frictionless, snow-covered hill on her inner tube. If the hill is inclined at an angle of 25 degrees to the horizontal, what will be the girl's acceleration due to gravity? You will notice that one thing is missing. The girl's what? Mass. What are we going to do? Well, we could do that. We could just give her a weight, right? Let's say that FD is equal to mg sine theta, right? Well, if it's a frictionless hill, there is no friction, right? And so the net force, which is equal to mass times acceleration, is in fact made up of only FD, right? Which means then that mass times acceleration is equal to mg sine theta, and guess what happens? I think I've told you this already. Well, that's cool. That's how simple it is. We talked about that already, right? The acceleration on a frictionless hill is g sine theta. So in this particular case, 9.8. Yeah? What's the angle here? 25? Pretty easy. Reminder that on frictionless hills, it's g sine theta.
Oh, yeah. Only hills?
Ramps, too.
Hills and...
Nope. Nope. Just wear a seatbelt on the hill on the ramp when you're going tubing. Okay, here's my friend Evel Knievel, and that is how you spell it, E-V-E-L. He's driving his motorcycle up a ramp at 30 degrees to the horizontal before jumping over a row of cars. If there's a constant frictional force of 1,000 newtons, determine... Oh. Go away. If there's a constant 1,000 newtons of friction, determine the force that the motorcycle engine must apply to accelerate up the ramp at 1/3 g. Have we talked about g's yet? Okay. Assume that the mass is 250. So 1g is simply 9.8 meters per second squared. You often hear about like test pilots and stuff like that pulling 4 or 5 g's, right? What it means is what's the acceleration? So 1g is 9.8, so 1/3 g would be 9.8 simply divided by 3. Right? When they say g-force, like gravity is 9.8 newtons per kilogram as well as meters per second squared because they're equivalent units. So g-force is newtons per kilogram. So 3 g's of force would be 3 times 9.8, like almost 30 newtons of force per kilogram. That's what they're talking about. So whatever this is, 9.8 divided by 3 is like a little less than 3.3, right? Like 3.2? Something like that? What is it? 3.26? Okay. That sounds familiar. 3.26. Okay, so meters per second squared or newtons per kilogram, right? Okay, so we want to know what the force of the engine must apply to overcome friction. Right? So I'm going to do it this way. I'm going to say that the net force, F net, is equal to mass times acceleration. Evel and his motorbike have a mass of 250. The acceleration is this 3.26. So the net force has to be 816.7 newtons. So far, pretty easy. That's 816. Okay. Now, think about this. Does the engine need to apply more than 816 newtons or less than 816 newtons? Why do you say more, Nate? Yeah, that's the target, right? That's how we have to get at, but there is friction, right? So we need actually more than that. Exactly. Cole, is that what you were going to say? Okay. No, I don't want to do this. Okay, so what I'm going to write now is I'm going to write that the net force is going to equal the applied force. Let me draw here. What actually, as he's going up the ramp, right, there's an applied force up, FA. Friction is down. Any other forces acting? The weight force down, right? But that's down, and remember the FD, right, is that component of the weight force that acts down the plane. So there is actually FD. So our net force is our FA plus our FF plus our FD, which we haven't figured out yet, have we? Remember, the weight force and FD are the same thing, right? FD is the part that goes down, right? We can figure that out pretty quick. So I'm going to see if I can slide all this over. I should be able to do it without the mouse. I don't like that. It's so much cooler if I can do that. He what? Does he? I'll have to get him to show me. FD is equal to mg sine theta, 250. Now, what do I use 9.8 for my g, or do I use the 3.26? Still 9.8. Oh yeah, yeah. Just testing you. What's my angle? 30. $12.25. Everybody with me so far?
Yes, sir.
And now what do I do?
Plug her all in.
Plug her all in and yeah, enjoy, right? Okay, now do I know FNet? Yes, I do. It's this 816, isn't it? 816.7. We are solving for the applied force. The friction force, now positive, negative here, Nate. What are we going to do? Friction is negative because it's opposite, right? Okay, so that's going to be, oh, it's given to us, right? It's 1,000, I think, right? And the FD, positive or negative? Also negative, right? Because it's down the ramp. Yeah, it's going to have a pretty good engine. Bring those to the other side. You're going to get 816.7 plus 1,000 plus 1225. I took these to the other side, and then I just switched both, right? Yeah, because no one likes the AFA, and no one likes the equals thing on the right-hand side. 3041.7. See, they need a physics dude working this out for him. Like, is his motorbike going to be able to do it? Right? You got to think that, yeah, the Sky Cycle. You got to think that nowadays the stunt guys got a lot better chance of making it because they figured it out ahead of time. No, it's not near as fun. Oh, I guess yeah. The risk is in, yeah. I don't know, Brandon's gone up to the board there or something. You okay, Brandon? Okay. Okay, so that's actually fairly easy, right? I mean, it's challenging. I wouldn't throw that to my grade 11 students, kind of thing, early in the course. But for us, I think it's in our comfort zone. Would you say, Nate?
Yeah.
Okay. Oh, you didn't like that last one? Okay. Now, what I did was the textbook doesn't do this, but I want to go one step farther and say, because that 1,000 newtons isn't really very reasonable. So what if instead of 1,000 newtons of friction force, what if I said the frictional coefficient is 0.15? That is more realistic. So what do we have to do here? Does the net force change? No. We still need that 8/16 of net force. Does the FD change? No, it doesn't change. The only thing that changes is the friction force, right? And the friction force is found from, that's getting annoying. The friction force is found from mu equals FF over Fn. We don't have Fn. No, it's not a disaster. We're going to make the canyon jump. Bingo. mg cos theta. mg cos theta. $250 times 9.8 times cosine 30 or 25? 30. 250 times 9.8 times cosine of 30, and you get, oh, I didn't do it this way here. What is it? Exactly 100? Oh, okay. That just seems like an awfully round number. Well, 250 times 9.8 is about 1,000. Making me look bad, Will.
Yeah, I got it.
Okay.
Hold on.
You're going to make Keith stand up and walk all the way to the board and correct me again. What is it? That much? Okay, yeah, that's 21, what? Okay, 2,120.6? 21.76. 2121.76. Gee, there's a big surprise. You got them started. I have to multiply by mu, right? So mu is 0.15 friction force over 21. That better be right, you guys. I get a friction force of 318.3. Yeah? No, I actually have that number written down here. I did it all in one step in my original plan here, but I didn't like it, and I've never fixed it. 318.3. Negative. And then now what? Now I just redo that first part instead of using 1,000, I use this number, right? So it's not that much harder, as long as you remember this guy, which is why I changed the question to remind you about that. Well. Okay, so it's going to be F net is equal to applied force plus friction force plus FD. The F net stays the same. Applied force is what we're solving for. Friction is this new guy here, minus 318.3. The FD stays the same. No, because the friction force has the Fn in it, right? 2360. That'd be a cool job to say. What do you do for a living? I'm Evel Knievel's physicist. I work out his calculations for him. Yeah. You'd be like the cool nerd.
Ethan.
Thanks, Nate. That means a lot.
I took absolutely 5 hours tutoring my physics teacher.
What? Yeah, I know. It just pained me to say yes. The evil Knievel's. You know what? One of the few things that I'm going to miss when I retire is showing that video. Because it always makes me laugh.
You can come here for a little.
Yeah? Guest lecture. Guest lecture. I will tell Mr. Smigalski when I retire, I want to come in and I want to teach that one section.
You need to retire next year?
No. I got a few more years left.
How old is
He's got 4 more years, I think.
When you get to retire at 55? Yeah, so
Yeah. Something like that, yeah. Yeah.